Today our topic is parallel and perpendicular lines. So our essential question is, how can I find the distance between two parallel lines? First off, a couple theorems from your resource sheet. Theorem 3.8. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So if we have a linear pair, it means they need to sum to 180. If the two angles are congruent, the only options to sum to 180 would be 90 and 90, which means right angles, which means perpendicular. Theorem 3.9. If two lines are perpendicular, then they intersect to form four right angles. That's our definition of perpendicular lines. They need to intersect to form right angles. So if we know that the lines are perpendicular, then we do have right angles. So example 1, in the diagram at the right, AB is perpendicular to BC. What can we conclude about angles 1 and angles 2? We can conclude 1, that angle 1 is congruent to angle 2. And that would be by theorem 3.9. And since angle 1 is congruent to angle 2, we know that they're both 90 degrees. They're both right angles. There's a lot of things we can conclude, but mostly that angle 1 is congruent to angle 2. Theorem 3.10, if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So we're saying that the sides of two of our angles make a right angle. Then the two angles that make up that angle should sum to 90 degrees. That should make sense. Since that makes sense, we should be able to write a proof about it. So example 2, we're proving that theorem. Prove that if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So we're given that ray ED is perpendicular to ray EF. So right here, these two are perpendicular, which means they form a right angle. So 1, the rays are perpendicular, is given. Number 2, angle DEF is a right angle. So since we have two intersecting rays, which technically are two intersecting lines, we can use theorem 3.9 that states if we have two intersecting lines, it forms right angles. Or two perpendicular intersecting lines. They form right angles. Number 3, measure of angle DEF is equal to 90 degrees. Well, if it's a right angle, it should equal 90 degrees, which means we're using that definition of right angle. Next piece, measure of angle 7 plus the measure of angle 8 equals the measure of angle DEF. So we're saying that the two pieces, 7 and 8, sum to form the whole. So that's our angle addition postulate, which is similar to your segment addition postulate, but it's for angles instead of segments. Measure of angle 7 plus the measure of angle 8 equals 90 degrees. We're replacing the measure of angle DEF with 90 degrees because we know that's what it's equal to. So that is our substitution property of equality. And then the last piece, angle 7 and angle 8 are complementary. Well, if they sum to 90 degrees, that means they are complementary. So that is your definition of complementary angles. Theorem 3.11, so 3.11, perpendicular transversal theorem. If a transversal is perpendicular to one of two parallel lines, it's perpendicular to the other. So we need to know that we have two parallel lines and that the transversal is perpendicular to one of those parallel lines. Then we can say that it would also be perpendicular to the other. That should make sense. Corresponding angles, same measure with parallel lines. Theorem 3.12, lines perpendicular to a transversal theorem. In a plane, if two lines, M and N, are perpendicular to the same line, they're both perpendicular to P, that means we can state that these two lines are parallel to each other. Also, that should make sense again, corresponding angles, same measure, you have lines that are parallel. Example 3, use the diagram. Is B parallel to A? So if we look at B and A, are they parallel to each other? We should be able to say yes, because they are both perpendicular to the same line. They're both perpendicular to D. So yes, they're both perpendicular to line D, which means we're using this theorem right here. Theorem 3.12, lines perpendicular to a transversal theorem. Is B perpendicular to C? Explain your reasoning. I would like you to try to answer that one on your own, and we will talk about that in class on Tuesday. Distance from a line. This is the last piece on your resource sheet. Main point of the notes. It's our essential question. The distance from a point to a line is the length of the perpendicular segment from the point to the line. This perpendicular segment is the shortest distance between the point and the line. For example, the distance between point A and line K is AB. You will prove this in chapter 5. Okay? So the distance from a point to a line, we want the shortest distance. We don't want to take the long way around. So we have the distance from line K to point A. If we took that distance, that's not the shortest distance. The shortest distance from point A to line K is the perpendicular segment. So the same thing for two parallel lines. It's going to be perpendicular segments between the two. So it's kind of like making those ladder rungs. You wouldn't want to make ladder rungs that are slanted. So we want that perpendicular distance. So this is a little bit of a review from 8th grade algebra, which you took last year. So example 4, we're going to need to use the distance formula. So the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, where x1 and y1 is a coordinate point and x2 and y2 are a coordinate point. Slope of a line. We have a couple different formulas for that. We have rise over run. We also have our slope is equal to y2 minus y1 over x2 minus x1. Again, coordinate points are being used there. Parallel lines have the same slope. Same slope. So they have the same rise over run. Perpendicular lines have slopes that are flipped and opposite. So what that means is if one slope was 2/3, the other slope would be flipped, so 3 over 2, and opposite, so negative instead of positive. Find the distance from point A to line C round to the nearest tenth. So distance means we need a perpendicular line from point A to line C. So first off, we need to make a perpendicular line to line C through point A. So if we look at line C, we need to find the slope. Since we're on a coordinate graph, we can use rise over run. We are rising 3, running 1. We're going up the mountain, so it is a positive slope. So line C has a slope of 3 over 1. So the perpendicular line would have a slope that is flipped 1/3 and opposite. So at point A, we're going to use that slope to form a line. We're going to go down 1, over 3. Down 1 over 3 would be off the graph, and then we can go up 1, left 3. Graph that line. So then the distance here is going to be the distance between these 2 points here. This is that perpendicular segment on the graph, and we would want the distance from A to that point right there. So we need coordinate points. Coordinate point of A, it's on the y-axis, so it has a 0 for its x-coordinate and 2 for the y-coordinate. For this point right here, it is at 3, 1. So we have x1, y1, x2, y2. find the distance. We use our distance formula, so distance equals the square root of x2, 3 minus x1, which is 0, squared plus y2, 1 minus y1, 2 squared. 3 minus 0 is 3, 3 squared is 9, plus 1 minus 2 is -1, -1 squared is 1. Square root of that, we have the square root of 10. And we can leave our answer as a square root of 10. Last piece here is find the distance between the two parallel lines round to the nearest tenth. Alright, so we need to find a perpendicular line through the two parallel lines. So parallel line, point, it has a slope of 1 and 1, and we're going down the mountain, so -1 over 1. So then a parallel line, not parallel, perpendicular line would have a slope of +1 over 1. So pick any point on parallel line 1, go up 1 over 1, up 1 over 1 until we hit the other line. Right there would be a perpendicular line. So we can find the distance of that line by finding our coordinate points. So that point would be 1, 1. That point would be 3, 3. And we can find the distance of that by plugging it into our distance formula. We get 3 minus 1 squared plus 3 minus 1 squared. 3 minus 1 is 2, 2 squared is 4. 3 minus 1 is 2, 2 squared is 4. Square root of 4 plus 4 would equal the square root of 8. So that would be the distance between those two parallel lines. That's all the notes I have for you. Thank you for watching this video, and please subscribe to my YouTube channel.